Hey there! In this video, I'll share with you an effective method for using dot cross diagrams to illustrate the bonding in ionic compounds. I'm Orlando Broomfield from Chemistry Core. Let's solve this chemistry exam style question together. A good place to start when working these problems is with the atomic number for each element. The atomic number for aluminum is 13 and that for oxygen is 8. This gives us important information. For example, it tells us the amount of electrons and also how the electrons are arranged on the shells. Yes, the atomic number tells us the number of protons, but an atom has no overall charge and the protons are positively charged, which means that there are equal amounts of protons and electrons in a neutral atom. So aluminum has 13 electrons and oxygen has 8. Now, using the rule that the first shell can hold a maximum of 2 electrons and the second and third shells can hold 8 electrons. Then we can write the electron configuration for aluminum 2, 8, 3 and that of oxygen 2, 6. Now let's draw a diagram for each of these atoms. So the symbol for aluminum, Al. The first circle there will be our first shell, and I will use dots, so that's 2 electrons. Then the second shell with 8 electrons, I'll go around one by one first, and then pair up, that's 8. And finally, the valence electron for aluminum with 3 electrons. Valence means last, so the last shell. Now we'll draw a diagram for oxygen, which can be confusing because the symbol is O and we're using circles for the shells. So that's the first shell, and this time I will use cross to represent the electrons on oxygen. So that's the first shell, the second shell with 6 electrons. Again, I'll go around one by one, then pair up. Now, this is the essence of ionic bonding. Ionic bonding involves the transfer of electrons from metals, in this case aluminum, to non-metals, in this case oxygen. And here's why. Aluminum has 2 choices to make. As it is not in a stable state because the outer shell, the valence shell, is not full. It does not have the maximum amount of electrons that it can hold, which is 8. So it has to decide whether or not to gain 5 more electrons or lose its 3 valence electrons so that the second shell becomes the new full valence shell. Now, in terms of energy, aluminum will find it easier to lose 3 electrons than to gain 5. Similarly, oxygen, in terms of energy, will find it easier to gain 2 electrons than to lose 6. Let's use arrows to show how the electrons will be transferred. So this pair will be complete here because this electron from aluminum is going to be transferred to this area, and the other single electron will have an electron from aluminum to complete the 8 electrons on the valence shell for oxygen. So oxygen now can be described as stable. But we have a problem because we have one single electron on aluminum that still needs to be transferred, which means we need to draw another diagram for an atom of oxygen. So valence shell with 6 electrons, 1, 2, 3, 4, 5, 6. So now this first atom of aluminum is now satisfied in terms of its need to become stable. However, we end up with this electron needing a partner, which means we need to draw another atom of aluminum. So Al, first shell with dots, second shell with 8 electrons, third shell with 3 electrons, 1, 2, 3, and transfer shown by the arrow there. But we have another problem on our hands. We have these 2 electrons which need to be transferred to an oxygen. Thankfully, we only need 1 more oxygen in order to satisfy the stability needs of this atom of aluminum. So 1, 2, and 6 valence electrons, 1, 2, 3, 4, 5, 6, and 2 arrows to show how the electrons will be transferred. We're at our final stage where we will show the compound, and let's make it easy for ourselves. We'll draw 1 ion of aluminum. Now it's an ion, no longer an atom, because it now is charged. It no longer has 13 protons and 13 electrons. It still has its 13 protons, but now it has only 10 electrons because it lost 3. So it has an overall charge of 3 plus. And let's put back the 2 electrons there. And let's draw the second shell, which is now the new full valence shell for aluminum ion. And let's do the same thing for oxygen. Oxygen will now have a charge of 2 minus because it has gained 2 electrons. That is, each atom has gained 2 electrons, and electrons are negatively charged. First it had 8 protons and 8 electrons. Now it has 8 protons but 10 negatively charged electrons. So with the first shell on with 2 crosses, and then this valence shell, we will show that electrons have been transferred from aluminum by having dots where there were no electrons. So we'll do that and that. So both of these ions now have stability in terms of electron configuration. We'll put square brackets around each. And it's time to show that we have 2 of these. So I'll put times 2 on this side, and 3 of these. So I'll put times 3 on this side. But we're not yet finished. We need to write the formula for the compound. Again, we write the elements, the symbol for the elements involved. Then we write at the subscript right position the amount of each atom in the compound, which is 2 and 3. And the name of this compound is aluminum oxide. Oxide because when nonmetals such as those in group 6 become ions, they take on the suffix IDE. And for ionic compounds, the name of the metal comes first. Thank you for watching another video on solving problems in chemistry with Chemistry Core. If you were tuned in, you are now able to use information given by the atomic number of metals and nonmetals, as well as information given by the formula for polyatomic ions, in order to correctly write the formula for ionic compounds. Good luck on your exams, and I'll see you next time.